Welcome back, Agent. Let's now discuss opening and reading files. In your recruitment bootcamp, you've actually already learned how to open a single file. However, often you're going to need to open every file in a directory or in multiple directories on the computer. Python's built-in OS module for operating systems can allow you to walk through files and folders on the computer as well as open them. The OS module functions and commands are also independent of macOS, Linux, Windows, or other operating systems, meaning that the same script you use to open and go through directories and files on your computer will work on any operating system as long as you use the OS module. Let's explore how to use this module by going to a notebook. Let's begin by quickly creating a file we can use to practice with. We will call this file practice.txt for a simple text file, and we'll say open with the mode W+, that way we can write this file because it doesn't exist yet. And then we're going to write a single line to this file, just test line or test, whatever you want, and let's close the file. All right, now let's discuss this built-in OS module. The first thing you need to do is actually import it by running import OS. There's many different methods and functions that are available off of this OS module. Let's discuss a few of the more basic ones. The first one is to actually get your current directory. To do that, you can type os dot, and if you hit tab, you'll realize all the various functions and attributes that are here. But the one we're going to be using is get and then cwd. This stands for get current working directory. And if you run this method or this function off of the OS module, it basically just reports back where this notebook is currently located. And if you were to run this in your script, it would run and return back the location wherever your script is currently located. So again, it returns back your current working directory. What's really nice about this is it returns back this string that you can then use to maybe pass along with an open statement to know what location certain text files are in. So that's getting your current working directory. If you want to list all the files in a directory, you can use os dot and then list dir, and that's for listing everything in your current directory. Obviously the results will differ depending on where you're located, but here you can see these are all the files I have located under this current directory. And you can actually pass in any directory you want. So for example, you can pass in your users directory, and it will return back everything that's in the users directory. So again, this is a basic list directory command, and if you just run it by itself, it prints out everything that's in your current directory. Again, to find out your current directory, it's get cwd, or if you want, you can pass in any folder or directory location, and it will list everything that's in that directory. Another very helpful built-in module in Python is the shutil model, or shutility module. Let's show you how to use it. We're going to import shutil, and this basically provides a lot of utilities for dealing with files on your computer. And later on, we'll see how we can use it for also zipping and unzipping files. Right now, we're going to show you how you can move files around your computer programmatically using this module. To move a file, you can say move, and you can see here basically it just takes two commands, src, that is the source of the file, and then dst, which is the destination of a file. Now remember, we actually have the practice.txt file we just created up here. So let's confirm that by running os.listdir. And if we run that, eventually somewhere in this list, you should find the text file you just created. So it looks like I have it right here, practice text file. I'm going to move this practice text file to, let's say, another user's file. So let's move it to this user's file right here. So we're going to scroll down here, and we're going to move the practice.txt file to one of the user's files. And note the actual syntax here. If you're on Linux or Mac, you're going to want to make sure that your forward slashes or backslashes follow the same syntax that is reported back to you when you say get CWD. Maybe you'll have single forward slashes on Mac or Linux computers. Follow that format. If you're on Windows, you'll follow the double backslash. Okay, so this is saying move this practice text file to this location on your computer. So when we run this, it reports back the final location of the file, so it looks like it moved it. Let's confirm that it moved it by listing everything in our directory again. And if we look back to P, we no longer actually have the practice text file there. So let's try moving it back to our current directory. So the way we can do that is through the following manner. Let's comment this out. We will again call the move function. We already know the location because it gets reported back, so you can copy and paste whatever it reports back as your source. And if we want to move it to our current directory, all we have to do is say os dot get current working directory and execute that function, because remember, this get current working directory just returns back your current working directory. So now this will go and grab that practice text file from this user and move it back to the directory we're currently in. And now it reports back where it is, and we can again confirm by listing out, whoops, let's make sure our syntax is all right there, by listing out our current directory. And we scroll down and we eventually see that yes, practice.txt file is back in our current directory. Now let's discuss deleting files. The OS module provides 3 methods for deleting files, and we're going to go show you them right now. There's os.unlink, and it takes in some sort of path parameter. So this deletes a file at the path you provide. So for example, if I wanted to delete this practice.txt file, I would just copy the entire path to it and then pass it into unlink, and it would delete the file at your path. There's also, and don't run these commands yet because we're going to still talk about them, there's also rmdir, which is remove directory, and that also takes in a path. And instead of a file path, you provide a folder path. And the folder must be empty in order for this to work. So unlink is for files, rmdir is for empty directories, and then finally, the one we're going to show you here is there's shutil.rmtree, and you can pass any path to that one as well. This one is the most dangerous out of these results because it will remove all files and folders contained in the path. So be extremely careful with this command right here, because all 3 of these methods cannot be reversed, which means if you made a mistake and you accidentally provided the wrong path, you will not be able to recover the file. So unlike normal delete commands on your computer where you can later look in your trash or your recycling bin and recover the file, using these OS level module methods, it's going to permanently remove the file in a way that makes it extremely hard or almost impossible to get back. So unlink, again, that's for a single file. rmdir, that's for an empty directory or an empty folder. Remove tree, if you give it a path, again, extremely dangerous command here, it will remove all files and folders permanently on your computer. Because these are so dangerous and it makes it really hard to recover files afterwards, what we're going to show you is the send to trash module. So to install the send to trash module, what you need to do is at your command line, type out pip install send to trash. So you need to install this library. Again, you do this at your command line, not inside the Jupyter Notebook. And what you can do to run command lines inside your Jupyter Notebook is try starting with an exclamation point. So if you run this, it should eventually install send to trash. And in this case, I already have it installed, so it worked all right. If you ever get an asterisk here that indicates that it's continually running forever, just go ahead and run this pip install send to trash at your command line. And make sure to use pip install. This library is currently not available with conda install. Again, run pip install send to trash at your command line, or you can try running it in the Jupyter Notebook by providing an exclamation point in front of it. Once you have send to trash installed, we can use that to send things to our trash bin or our recycling bin. That way, just in case we accidentally deleted something that we still need, we can always recover it. And it's quite simple. All you need to do is say import send to trash, and then let's go ahead and list what we have currently. Here it looks like we have our practice.txt file. Let's go ahead and send that to the trash. And the command is quite easy. It's just send to trash dot send it to trash, and then the file path. In this case, because I'm in the same directory as this text file, I can just copy and paste that in, run that, and it's been sent to my recycling bin. And this is a safe way to delete things on your computer using Python because the files are recoverable in your recycling bin or in your trash. Programmatically, you may see unlink, rmdir, remove directory, and then remove tree used in scripts, but you should be very, very careful with these commands because they will permanently delete things off of your computer in a way where you cannot recover them. So I recommend using send to trash in order to safely delete things on your computer. Okay, we've discussed getting directories, listing everything in a directory, moving files around on your computer, as well as sending things to the trash. The last thing I want to discuss is walking through a directory. To walk through a directory, you can just use the os.walk function. Now first off, I'm going to create a variable called myPath and set it equal to the same path where the corresponding notebook for this lesson or this overview is located. So let me copy and paste that here. Basically, I'm just passing in where the orange mission folder is and setting that as myPath. Or you could alternatively use your current working directory. So you could set myPath equal to os.getcwd. Just keep in mind your results may look a little different than what we have here if you use this approach because you may go through different folders or different subfolders. So I'll just set my path to the orange folder location. And then what we will do is show you how to use OSWalk. So OSWalk uses a little bit of tuple unpacking because it's going to return back three main pieces of information. The folder it's looking at, the current subfolders it's looking at, and then the current files it's looking at. And then you say an os.walk, and then whatever directory you want to walk through. So we'll say my path. And then let's just print out the folder we're looking at. So what this does is it says, I'm going to be checking through all these folders. So it first starts with the top level folder, and then it looks like at different examples. Example top level, example extracted contents, and all these various folders there. Then there's also the subfolders. So we can print the folder. And let's write a message here to make it a little clearer. Currently looking at folder. And then we print that folder. And then we can print the subfolders for it. Subfolders here are, and then subfolder is essentially a list of subfolders in that folder. And you can think of folder as another word for a directory. So we can say for subfolder in the list of subfolders, plural there, print out the subfolder. And then we're going to, at the end of this, print, well, let's print a new line here. So I run that, and it says I'm currently looking at this folder right here, and it looks like the three subfolders here are this checkpoints folder, this example top level folder, and this mission orange files folder. And then it looks like another folder, and it doesn't find any folders inside of that one. So notice how it's basically recursively walking through every single folder and subfolder and seeing what's in there. Sometimes it won't find any subfolders. So you can see here in this IPython notebook checkpoints folder, it didn't find any other folders there. That means after there's no more folders left, there's probably only files left, or it's just an empty folder. To see the files, you can just say for f in files, print f. And then we can print a new line after this. And if we run that, it's going to look through more things. So it says, hey, I'm currently looking at this folder. Here are the subfolders. And then it prints out all the files that it found there in those subfolders, and it continues. And you'll end up getting repeated results here, because if it looks at certain folders multiple times, you'll see repeated results. But basically what it's doing is just recursively walking through every single folder. and we've gone ahead and inside the orange mission folder, there should be some clear examples called mid-example1, mid-example2, bottom level 1, bottom level 2, and then there's also top level folders, example top level, and that's just designed to help you understand how this walk is currently happening. But basically all it's doing is, again, you provide it a file path and it will look for every folder, every subfolder, and every file in that particular path. And this is a nice way to allow yourself to interact with some sort of, or through some sort of functionality for every file in a directory. So you can imagine that if you needed to open every single file that was in a group of folders inside another folder, you could just use the OS walk on that path that eventually points to every single file. So eventually here, instead of maybe printing F, you would say, hey, why don't I open these files, and then maybe I can write to them somehow. It's really up to you what you're going to be doing with those files, but hopefully you get the idea. Again, that's using the os.walk function. You should now be aware of how to work with a computer's files and folders in whichever directory they are in. Remember that the OS module works for any operating system that supports Python, which means these commands will work across Linux, macOS, or Windows computers without any need for adjustment, so you can share scripts that use the OS module command across different colleagues working on different computers. Keep in mind that the only time you will need to make an adjustment is if you're manually providing file paths like we did up here. If you're doing that, you're going to want to make sure to be using the correct syntax for your operating system. And if you ever need a reminder of what that syntax looks like, all you need to do is run the getcwd command, and it will output the file or the current directory you're in the syntax it expects. So for Windows computers, it looks like it's expecting 2 backslashes per folder. All right, hope that was helpful to you, Agent. Best of luck on your next mission.